Have you ever wondered how multiple devices in your home connect to the internet using a single IP address? This question might sound a little puzzling, but the answer lies in the heart of how our digital world operates. You see, every device connected to the internet has a unique identifier, known as an IP, Internet Protocol Address. Think of an IP address as a digital home address. Just as you would need a physical address to send a letter, devices need an IP address to send and receive data. It's the fundamental way our devices identify and communicate with each other in this vast digital universe. But here's a twist. There are only so many unique IP addresses available. And with the explosion of internet-connected devices, from smartphones and laptops to smart home devices and beyond, we've quickly outpaced the number of available addresses. So, how do we connect all these devices without running out of unique identifiers? Enter the concept of NAT, or Network Address Translation. NAT is like a digital switchboard operator, managing the traffic between your home network and the broader internet. It enables multiple devices within a local network like your home or office to share a single public IP address. This means your laptop, smartphone, and smart TV can all use the same public IP address to connect to the internet while maintaining unique private IP addresses within your home network. In essence, NAT acts as a translator, mapping your private IP addresses to a public one, and vice versa, allowing data to flow smoothly between your devices and the internet. This ingenious solution not only conserves the limited pool of public IP addresses, but also enhances your network security by keeping your private IP addresses hidden from the rest of the world. So NAT, or Network Address Translation, is our hero. But how does it work? Well, stay tuned, because in the next scene, we'll delve into the different types of network address translation and discover the magic behind this essential internet function. There are three different types of NAT: static, dynamic, and port address translation. To start with, we have static NAT. This is the simplest form of network address translation, where a single private IP address is directly mapped to a single public IP address. It's like having a dedicated line between 2 points. This is often used when a device needs to be accessible from the outside world, say, a web server or an email server. However, the downside is that it requires one public IP address for each private IP address, which can be expensive and not very scalable. Moving on, we have dynamic NAT. This type operates a little differently. It assigns public IP addresses from a pool to private IP addresses on a first-come, first-served basis. Think of it as a busy restaurant where tables are assigned to customers as they arrive. This method is more scalable and cost-effective than static NAT, as it allows for the sharing of a limited number of public IP addresses among a larger number of private IP addresses. However, since the public IP address can change, it can cause problems for services that require a consistent IP address. Lastly, we have port address translation, or PAT. This is the most common type of NAT and the one you're likely using at home right now. PAT allows multiple devices to share a single public IP address by assigning different port numbers to each private IP address. It's like an apartment building where everyone shares the same street address, but each apartment has its own unique number. This allows for a large number of devices to connect to the internet using a single public IP address, making it extremely efficient and cost-effective. However, it can also lead to port conflicts if two devices try to use the same port number. Each type of NAT has its advantages and disadvantages, and the choice depends on the specific needs of the network. Whether it's the simplicity and consistency of static NAT, the scalability of dynamic NAT, or the efficiency and cost-effectiveness of PAT, there's a type of NAT for every situation. So how does NAT work its magic? You may wonder, well, it's a fascinating process, and it all begins with your router. You see, your router is the unsung hero of your home network. Quietly, and efficiently managing all the data traffic that goes in and out. Think of your router as a diligent librarian. Just like a librarian maintains a catalog of all the books in the library, your router maintains a table of all the private and public IP addresses being used in your network. This table is called a NAT table or a translation table. When a device inside your network, say your laptop, wants to send a data packet onto the internet, it sends this packet to the router. Now this packet has the laptop's private IP address stamped on it. The router, acting like a diligent librarian, looks up this address in its NAT table. If it finds a corresponding public IP address, it swaps the private address with the public one. If the router doesn't find a corresponding public IP address, it creates a new entry in the NAT table and assigns a public IP address to your laptop's private one. But how does the router handle incoming traffic? Let's imagine a scenario where a server on the internet sends a packet to your router's public IP address. When the router receives this packet, it looks up the destination IP address in its NAT table. If it finds a corresponding private IP address, it swaps the public address with the private one, ensuring the packet reaches the right device in your network. Now, let's talk about how the router handles multiple devices. In a typical home network, there are multiple devices connected to the router, each with its private IP address. When these devices send data packets to the router, it uses the NAT table to map each private IP address to the public IP address. This way, the router can manage traffic from multiple devices using just one public IP address. The same process applies when the router receives incoming traffic. It uses the NAT table to determine which device in your network the data packet is intended for, based on the private IP address mapped to the public one. So far, we've assumed that the router has a single public IP address. However, in larger networks, the router could have multiple public IP addresses. In such cases, the router uses a process called port address translation, or PAT, to map multiple private IP addresses to multiple public ones. But that's a topic for another day. NAT, in essence, acts like a translator and a traffic cop, ensuring that all data packets go where they're supposed to. It provides a way for multiple devices in a network to share a single or few public IP addresses, making the internet more efficient and secure. And that, my friends, is the magic of network address translation. Oh, why is NAT so important in our networks, you may ask? Well, let's unravel that mystery. Firstly, NAT plays a pivotal role in conserving IP addresses. The internet has grown exponentially since its inception, with billions of devices now connected worldwide. However, the number of available IP addresses has not grown at the same pace. The IPv4 protocol, which is still widely used today, has a little over 4 billion unique addresses. That might sound like a lot, but when you consider the sheer volume of devices connected to the internet, it's clear that we would have run out of addresses long ago without NAT. NAT helps us conserve these addresses by allowing multiple devices within a local network to share a single public IP address. This means that each device doesn't need its own unique public IP address, saving us from the risk of running out. But the importance of NAT extends beyond just conservation. NAT also allows for the creation of private networks within homes and organizations. This is crucial because it enables multiple devices to connect to the internet simultaneously using a single internet connection. So whether it's a family streaming movies on different devices at home or an organization with hundreds of employees all accessing the web, NAT makes it all possible. Moreover, NAT enhances network security. When a device within a local network communicates with the internet, the public IP address of the router is used, not the private IP address of the device. This masks the private IP addresses of devices within the network, making it harder for malicious actors to target specific devices. So, as we can see, NAT is a cornerstone of our modern internet structure. It conserves valuable IP addresses, allows for the creation of private networks and enhances security by masking private IP addresses. Without NAT, our current internet structure with its billions of devices would simply not be possible. It's just another piece of the complex puzzle that makes our connected world work. So, let's recap what we've learned about network address translation. NAT, as it's commonly known, is the process that enables multiple devices on a local network to share a single public IP address. It's the unsung hero of our internet connections, working behind the scenes to ensure smooth and efficient data transfer. We delved into the three types of NAT: static, dynamic, and port address translation. Static NAT creates a one-to-one relationship between private and public addresses, while dynamic NAT uses a pool of public addresses. Port address translation, or PAT, maps multiple private addresses to a single public address using different ports. We also explored how NAT works, translating private IP addresses within a network to a public IP before the data hits the internet. And we discussed why NAT is so vital, especially for organizations that need numerous devices to use a single IP address. The next time you connect multiple devices to the internet, remember the crucial role that NAT plays in making that connection possible.